and today we're going to be naming and drawing IUPAC compounds in the perspective of IUPAC, right? For organic chemistry in the unit of alkynes, right? So hopefully you've been through most of the chapters now. This should hopefully be in one of the final chapters you touch on potentially in your Organic Chem 1 class. So we're combining some topics we learned, adding in some new stuff. Alrighty, so grab a piece of paper if you'd like and try these two problems here. I'm asking you to name this compound here and draw this one based off of the IUPAC name. So you can pause the video now and try it out if you'd like. Okay, so I'm gonna go with the drawing first because I'm the artistic type. I don't really like naming, so how I approach these problems is I look at the name and I go for what's the parent chain gonna look like. I see hept here and we know hept means 7, a 7 carbon chain parent. So we can draw that in right away. So we'll go 1, 2, 3, 4, 5, 6, 7. Okay, well, it's saying at the third position we have an alkyne. Now when you have anything with an alkyne in it, it's better to draw that first. And I say that because it changes the geometry of the molecule and you don't want to do that last and have to erase everything, all the substituents that you've already put on, when you can just draw it in the first place. So at position 3 we have an alkyne. So if we go 1, 2, 3, it's going to be there, so we'll get rid of that part of the molecule for now. 1, 2, 3, we're going to go put our triple bond in, right, because that's what an alkyne is. And then like that. Remember that this has linear geometry and it's going to be linear. So 1, 2, 3, 4, 5, 6, 7, right? So that's heptyne. Alrighty, well let's look at what we can add now. We're going to skip the amine for now because I think that's the new stuff and we should make it as easy as possible on ourselves, right? So let's see here. We have in position 7, we have a fluoro group. So let's count 1, 2, 3. Oops, sorry, almost. 1, 2, 3, 4, 5, 6, 7. So we can draw the fluoro extruding from that carbon. Okay, and then at position 5, we have a methoxy. Hopefully you remember what a methoxy is, an oxygen. So 1, 2, 3, 4, 5. So we draw that first, that oxygen. We just kind of draw an ether in there. Alrighty, let's get to the hard part, the part we were not looking forward to, and that is the amine. So how do we draw this amine? So what we're going to do is we're going to find position 2, right? Because that's where the amine's located. It's going to be right here. And if you look at the front, this might look new to you. N-cyclopentyl and ethyl, that just means it's connected to that nitrogen atom. So amines comes out like that. We have an ethyl group protruding from it because it says N-ethyl. So an ethyl protruding from the N, the nitrogen. And then cyclopentyl. Cyclopentyl is just, we know pentane is 5 and a ring is cyclo. So we'll just draw in cyclopentyl group. And that is our molecule right there. Pretty easy, I'd say. Nothing too crazy. Alrighty, well let's move on to naming this bad boy. There's a lot to unpack here. It's not as obvious. Alrighty. So, you always want to include the alkene here, the alkene part. So, and we know that alkenes and alkynes are equivalent in their priority. So it's whichever one you can reach the fastest, right? And there's no other groups here that take over priority, so our highest priority is the alkene or the alkyne. So I noticed that we can make this carbon 1 and we can reach that alkene right off the start. And we go 2, 3, 4, 5, 6, 7, 8. So looking at this, I know this is octane or octine, right? Octenine. Whoa, that's a big word salad right there. So we know that we're gonna have some sort of oct in there. Alrighty, we have this chloro group here, ethyl chloro group. So we're just gonna, this is a complex substituent. So we'll name this 1-chloroethyl, right? We're just gonna go around all the substituents and name them. Take a guess what this is here. This one might be a little tricky for you. This is gonna be, notice how it kind of looks like isopropyl, but it's butyl, so we just say it's isobutyl, right? Since we have 1, 2, 3, 4 carbons, and it kind of looks like that isopropyl flower group, as I say. All right, and here we know that this is a phenyl group. Remember that phenyl groups are directly connected to the carbon chain, while benzyl groups have a buddy carbon. So this is a phenyl here. This is phenyl. Alrighty, now we'll get to naming this. So remember, it's alphabetical order, and just looking at this, we know that the 1-chloroethyl should probably be at the front. So, and it's on carbon 2, so we go 2, 1, in parentheses 1-chloroethyl. 1-chloroethyl. Our next substituent, remember your ABCs. Every time I do these problems, I'm singing the ABC song. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So we're gonna go for isobutyl next. That's in position 3, so we'll say 3-isobutyl. Take note of what we have right now. I notice at 6 we have a phenyl. So we're gonna write 6-phenyl because that comes next in the alphabet. All right, and now it's time for the parent. How exactly do you name the parent here? A second here. All right, so you need to, a good mnemonic I have is enine. That when you're naming the parent, and when you have an alkene and an alkyne in there, you need to know that this mnemonic enine, right? So you're gonna go ene and then tell them where the ine is. This will make sense in a second, I promise you. Okay, so in the first position, we're gonna go for the alkene first. So we have 1, and then we have octane, or an octane parent, but remember we have the ine and the ene, so we're gonna go octene, and then we know that this starts at 4, so we'll put 4 ine. Alrighty. That is how you name that molecule there. 2-chloroethyl, 3-isobutyl, 6-phenyl, 1-octene, 4-ine. Alrighty. Pretty simple. Hope you guys enjoyed this video. Remember the rule, there's a common misconception here that you have to go that way. You don't want to go that way, and I only say that because if you don't go through your alkene, it gets complicated. So you always want to go through the alkene or the alkyne. Alrighty, thank you guys so much for watching. Have a wonderful day.